So today ang topic natin is Advanced Engineering Mathematics. So ito I usually take uh, sa new curriculum is second year and sa dating curriculum is third year. So ang prepare kong topic today, meron tayong 3 parts lang kasi medyo mahaba siya. So first part, we will discuss complex numbers. And then for part 2, Laplace Transforms. And for part 3, we will discuss matrices and vectors. Isama ko pa sana yung ibang topics, kaya lang medyo makukulangan tayo sa time. Okay? So let's start with the part 1, which is complex numbers. So ito yung discuss natin, 6 topics. From introduction up to solving inverse, trigonometric, and hyperbolic functions. So first, bago tayo proceed, define muna natin yung complex number. So ang complex number, this is any number in the form z is equal to a plus jb. Sa ibang references, itong form na to is also z is equal to a plus bi. Kasi may mga books na ito yung gamit. Z is equal to a plus bi. So where your a in here is and b are real numbers. And your j or I, in this case, is the imaginary unit. And also, yung imaginary unit na yan, j, that is equal to square root of negative 1. So some examples of complex numbers, we have j2, we have 3 plus j5, negative j3, and negative 4 plus j2. So when your a is equal to 0, the number is said now to be pure imaginary. So example niyan, ito yung j2 and yung negative j3. And then when b is equal to 0, yung number naman is real. Okay? So yung real numbers ay special case ng ating complex numbers. So yung form naman na x plus jy, yung nandito, this is used to indicate the general complex number and denoted by z. So pag z, that is complex number. So, and then, katulad na sabi ko kanina, this is, yung j is imaginary unit. So yung real number x in z is equal to x plus jy, that is what we call the real part of z. It is abbreviated as REZ. And yung y naman, that is the imaginary part of your z. That is abbreviated as IMZ. And then first, kasunod natin is equality of complex numbers. So ang complex number, z1, which is x1 plus jy1, and z2, which is equal to x2 plus jy2, is said to be equal. Okay, equal yan if they have the same real parts and the same imaginary parts. So, meron tayong tatlong cases dito. So first, if your x plus jy is equal to 0, then we can say that your x is 0 and y is equal to 0. Okay. And then second, if your x1 plus jy1 is equal to x2 plus jy2, so sabi natin, di ba, equal siya if meron kang same real parts and same imaginary parts. So, kapag equal itong dalawang to, so we can say that x1 is equal to x2, that's the real part, and y1 is equal to y2. This is the imaginary part. And last, if we have x1 plus jy1 times your x2 plus jy2, if that is equal to 0, then we can say that either your x1 plus jy1 is 0 or x2 plus jy2 is equal to 0. Example for equality, meron tayo dito example. So if 3x minus 5 plus j 4 times the quantity 4x plus 3 is equal to y minus 4 plus j times the quantity 3x plus y, find the values of x and y. So, sabi natin, di ba, equal yung real part to real part and equal yung imaginary part sa imaginary part. So, from this given, on the left side, okay, so yung x, I mean yung 3x minus 5, this is the real part on the left side. While on the right side, yung real part natin is itong y minus 4. And then, balik tayo sa kabila. Ang imaginary part naman dito sa kabila, on the left, is ito, yung kasama ng j, which is 4x plus 3. And on the right, we have 3x plus y. So, sulat natin yan. We have real, that is 3x minus 5 is equal to y minus 4. And then, imaginary, that is 4x plus 3 is equal to 3x plus y. So, ito, we have two equations and two unknowns. We have x and y as unknown. Okay? So solve natin to by using your techniques in algebra. Okay? So, solving for x and y, we have x is equal to 2 and y is equal to 5. So, para natin ito isosolve. So, kung i-algebra natin to, so from this first equation, so gawin natin siyang, pwede natin gawin na y is equal to 3x minus 5 plus 4. Or simplify natin, that is 3x minus 1. And then, substitute natin on this second equation, sa imaginary. So we have 4x plus 3 is equal to 3x plus your y, which is this one, 3x minus 1. So by algebra, we have 4x plus 3, that is equal to 3x. So gawin na natin, so we have 3x plus 3x, so that is 6x. So we now have 6x na, and then minus 1. So we have, so lipat na natin to. So we have, lipat natin yung 1 sa kabila. So we have 3 plus 1, that is equal to 6x. So minus 4x. So we have 4 is equal to 2x. So yung ating x is equal to 2. So we have this, we have the x is equal to 2 as our answer. And then for y, so from this equation, sa taas na to, substitute natin yung 2. So substitute natin yung 2. So we have y is equal to 3 times 2 minus 1. Okay, so we now have 6 minus 1, that is 5. So ganyan lang yung pag-solve natin on finding for the values of x and y on this complex number, okay, equation. So equation 5, 1. So two equations, two unknowns. We have 3, negative 5. Simplify ba to? So we have 3x and then yung y natin. So we have negative 1 and then yung ating simplify natin to. So we have, so y, di ba? Y is equal to 3x minus 1. So we have 3x minus y is equal to 1 for the first equation. And for the second equation, this is 4x. So we have x minus y is equal to negative 3. So try natin yan. So we have this one, and then x, then to, and then to. Yan, so 2 and 5. So we can use yung ating mode 5-1 to solve for two equations and two unknowns. And then, proceed na tayo on the forms of complex numbers. So we have 4 forms. So the first form is rectangular form. So that is z is equal to x plus jy. Okay, so yung x natin is the real part or component, and yung y natin is the imaginary part or component. And then, second form is what we call polar form. So we have this form. So yung r natin is the magnitude or amplitude. And your theta is the argument or displacement in degrees. And then, itong symbol na to, that is read as your bar angle. Next form is the trigonometric form. So we have z is equal to r times the quantity cosine theta plus j sine theta, or that is r c j s theta, or kung this is I operator, we have r c I s theta, or that is r cis theta. And last, the same, we have r magnitude and theta is argument. And last form ng ating complex number is exponential form. So we have z is equal to re raised to plus or minus j theta. Take note, sa exponential form, yung theta natin dito is naka-radians. So next, we proceed now to graphical representation ng complex numbers. So yung ating complex numbers can be represented in an R-Gantt diagram. So by plotting the real part on the x-axis and the imaginary part on the y-axis. And then, from the figure dito, we can solve for the tangent theta. So we have that is y over x. And we can solve for theta, that is arctangent of y over x. So we have what we call modulus. So ang modulus, that is written as ito. So absolute value, parang absolute value yung symbol of z. And that is the length of your r. So itong length na to, that is the modulus. And that is equal to the square root of x squared plus y squared. So ginamit natin dito is Pythagorean theorem. And sabi natin yung theta, ayan, that is the angle made with the horizontal axis. This is noted by your bar angle. So para makuha yung angle theta, so ito yung ating formula. We have arctangent of y over x. Meron din tayong conversion kasi meron tayong mga forms, di ba? Iba-ibang forms. So we can convert between the different forms. So una is convert tayo from rectangular form to polar or exponential form. So to convert rectangular form to polar or exponential form, yung r natin, that is again square root of x squared plus y squared. So by using Pythagorean theorem. And then your theta is arctangent of y over x. And then from polar or exponential to rectangular form, so we can use your trigonometric identities, okay? So since ito, di ba, yung x na kinukuha natin, di ba? Rectangular form in x and y. So pag makuha yung x, the relationship between your x and r is cosine. So we have that is cosine theta. So we have katawa, di ba? So that is opposite over the hypotenuse. So we have ano ba to? Katawa. Adjacent pala. Katawa. So we have cosine, di ba? Muna pala yung cosine ko. Okay, so again, cosine theta, katawa. So ka. So ka, CAH, so cosine, that is adjacent in this angle. So we have x over r. So that is the hypotenuse. Naisip ko agad yung sine. Okay, and then for the sine theta, ayun. Okay, ito yung opposite. So opposite over the hypotenuse. So we have y over r. So and then we now have to solve for x, that is r cosine theta, and y is r sine theta. So take note, so pag mag-convert tayo between the different forms ng complex number, maggawa tayo ng quick sketch. So para makita natin yung angle. So para kung nasa ibang quadrant yung angle, so this is quadrant 1, quadrant 2, 3, and 4. Okay? So pag nasa iba yung pag nasa ibang quadrant, so pwedeng i-adjust lang yung angle as necessary. Okay? So I think may example tayo. Ito. So express z is equal to 3 plus j4 in polar and exponential form. So sabi natin, polar and exponential form. So this is the given in rectangular form. So to convert that, we solve first for the r, or modulus, that is equal to the square root of 3 squared plus 4 squared. So 5 yung ating r. And then solving for the angle, that is arctangent of y over x. So we have 4 over 3. That is equal to 53.13 degrees. That is in degrees. And sa radian, this is 0.9273. So pag polar form, we have z is equal to 5, bar angle 53.13 degrees. And exponential form, that is z is equal to 5 e raised to j 0.9273. So ito yung ating polar form and exponential form respectively. So kung makita natin yung graph, kasi ito naman sa quadrant 1 naman to. Kasi we have the real part of your Argand diagram and the imaginary part. So we have 3, 1, 2, 3, para ka lang nag-drawing sa Cartesian plane. So, and then sa imaginary, y-axis yan. So we have 4, 1, 2, 3, 4. Okay? So ito yung ating, this is our 5. Okay? And then yung angle na nandito is 53.13 degrees. So hindi natin kailangan i-adjust yung ating angle. Hindi naman siya nasa ibang quadrant. Okay? So ang reference natin for your graph, itong nasa positive real axis, yung reference ng ating angles. And then another example is express 7e raised to j pi over 3 in rectangular form. So take note, this is in exponential form, yung itong given natin. So take note na yung pi over 3 is in radians. Okay? So solve natin yung x. Okay? So we have 7 cosine times pi over 3. That is equal to 3.5. And then y is equal to 7 sine times pi over 3. That is 6.062. So take note, pag sa calculator, pag in-input nyo ito, dapat naka-radian kayo, ha? Okay? And then, in rectangular form, this is now z is equal to 3.5 plus j 6.062. Okay, so that is how we convert into the different forms of your complex numbers. So pakita ko rin sa calculator paano natin to i-convert. Okay, so to convert complex numbers, we use yung mode 2. So we have 2 is complex. So press natin yung 2. So to convert yung rectangular to polar, so ang gagawin natin is input lang natin yung yung complex number. We input the complex number. We have 3 plus j4, or wala tayong j sa calculator, so that is I. So we have 3 plus 4i. So convert lang natin to polar. So shift 2, that is complex. And then meron tayong apat na options. So we choose itong r bar angle theta, number 3. And then lalabas na yung ating sagot. So we have 5 bar angle 53.13. Okay, while kung exponential form naman, ang gagawin lang natin, i-change natin yung degree, ito sa mode natin sa calculator. Gawin natin yung setup, gawin natin radian. Okay, gawin natin radian. So lalabas na yung 0.9273. So we have 5 e raised to j 0.9273. So kapag naka-radian, so we can obtain yung ating exponential form. So ito yung ating angle, yung 0.9273. And then kung ano naman ang given, ito di ba exponential, ito exponential. So okay na to, naka-radian yung calculator natin. Okay? Input natin yung 7 cosine pi over 3. So dapat kayo ay naka-radian. Dapat lagi yung titignan yan. Ayan, 7 over 2 or 3.5. Marami kasi nakakamali dito. And then, pag kapag y naman sine, so we have, that is 6.062. So, tandaan nyo lang lagi na dapat check nyo lagi yung setup ng calculator nyo, kung naka-degrees ba yan or radians. Kasi marami nagkakamali talaga dito ng mga students natin. Okay? So, natapos na tayo sa introduction. We will now proceed to arithmetic operations. So, we have arithmetic. We have addition, subtraction, multiplication, and division. So, first, addition and subtraction tayo. So, to add two complex numbers, so we simply add or subtract the corresponding real and imaginary parts. So, this is in a rectangular form. So, add lang natin. So, we have x1 plus jy1 plus x2 plus jy2. So, real part to real part, add natin. So, x1 plus x2 plus j times your y1 plus y2. So, add lang natin yung real part to real part and imaginary to imaginary. Same with subtraction. Subtract real part to real part and imaginary part to imaginary part. And then the next is multiplication. So when you multiply two complex numbers, we carry out the multiplication as in ordinary algebra. FOIL method, pwede rin gamitin dito. And we use the result that j squared is equal to negative 1. So, FOIL method, so we have two complex numbers, x1 plus jy1 and x2 plus jy2, multiply natin. So, we have x1, x2 plus jx1, y2, and then plus jy1, x2 plus j squared, y1, y2. And then yung j squared natin is, sabi natin, negative 1. So this will now become negative. So we have x1, x2 minus y1, y2 plus j times the quantity y1, x2 plus x1, y2. Example, so if j1 plus, that is equal to 2 plus j4 and j2 is equal to negative 3 plus j8, we need to solve for j1 plus j2 and j1 times j2. Okay? So solve natin to. So for letter A, so j1 plus j2, so we have 2 plus j4 plus negative 3 plus j8. So real part to real part, 2 minus 3. And then imaginary part, we have 4 plus 8. So we now have 2 minus 3 is negative 1 plus j, 4 plus 8 is 12. So, ganun lang mag-add. And then, kung multiplication naman, so we have to multiply these two complex numbers. So, we apply FOIL method. So, we have 2 times negative 3. So, that is negative 6. And then, 2 times j8. That is plus j16. And then, j4 times negative 3. That is negative j12. And last, we have j4 times j8. That is 32j squared plus. Okay. So, this 32j squared becomes negative 32 since j squared is equal to negative 1. So, we have negative 6 minus 32 plus we factor out j. So, we have j times the quantity 16 minus 12. So, we have negative 6 minus 32 is negative 38 and plus j, 16 minus 12 is 4. So, on your calculator, kung gusto natin ng calculator technique nito, you just enter yung ating complex number. So, dapat nasa ano kayo? Nasa complex, nasa mode, complex mode kayo. And then, so, J1 plus J2, sabi natin, di ba? So, 2 plus J4, or that is 4i. So, input lang natin sa calculator, 4i, sa eng banda. Plus yung ating negative 3 plus j8, or that is 8i. So pag input sa calculator, so we have this one as our answer. So we have negative 1 plus j12. Okay? And then, pag multiplication, ganoon din ulit. Input lang natin, gawin natin times ito. Okay? So we have our answer. Yun, no? Negative 38 plus j4. So, pag arithmetic operation sa ating complex numbers, you can use your calculators para sa board exam, para mabilis, di ba? So, next concept is conjugate. Ito muna discuss natin before we proceed to division. Kasi ito yung concept for division, yung ating conjugate. So, if Z is a complex number, then the number obtained by changing the sign of its imaginary part is called complex conjugate. So, pag binago natin yung sign ng imaginary part ng ating complex number, that is now called the complex conjugate or simply conjugate of Z. If your Z is equal to X plus JY, then yung conjugate nun, we have your Z bar. So this is your, ito yung nagre-represent for a conjugate. So we have Z bar that is equal to X minus JY. So papalitan lang natin yung sign ng imaginary part. So from positive, naging negative. Or from plus, naging minus. Okay? So may example ako dito, papakita. This is Z, and then, this is Z bar. Hindi ko alam kung bakit hindi nasama yung bar. That is Z bar. Ito, Z bar. So, ito yung ating complex number. So, 6 plus J3, yung conjugate niyan is, papalitan lang natin tong plus ng minus. So, we have 6 minus J3 as its conjugate. And then, kung ito naman, negative 5 plus J, so, palitan natin yung sign ng imaginary. Itong minus, gagawin natin plus. So, we have negative 5 plus J. And then ito, 7 ang given. Okay? Baka ang sagot, negative 7. Okay? So, pag hinahanap ang conjugate ng isang complex number, pag walang, so ito ay walang imaginary part. So, as is yung ating answer. So, we have 7. And then last, J4, so this is a purely imaginary number. So from positive, gagawin natin negative yung J4. So that is how we obtain or we get conjugate of a complex number. So itong conjugate na concept, gagamitin natin for division of complex numbers. So in division, if to divide Z1 by Z2, we multiply both the numerator and the denominator of the Z1 over Z2 by the conjugate of your Z2, or that is the conjugate of Z2. So, so we have Z1 over Z2, that is X1 plus JY1 over X2 plus JY2. Multiply natin sa conjugate nitong X2 plus JY2, both numerator and denominator. So, we have X2 minus JY2 over X2 minus JY2. So, yan ang ating division. And then, apply tayo ng FOIL method on the numerator and then on the denominator. And then, kung mapansin niyo dito, so we have, dito sa denominator, so we have X2 squared plus J squared X2Y2 plus J squared X2Y2. So, we have negative J squared X2Y2 and positive J squared X2Y2. So, we can cancel this one. And then, sabi natin yung J squared is negative 1, di ba? So, this will now become X1, X2 plus Y1, Y2. Okay? Over X2 squared and then plus, magiging positive na to, Y2 squared plus your J, Y1, X2 minus X1, Y2 over X2 squared plus Y2 squared. Okay? Example for division. So we have Z1 is equal to 2 minus J3 and Z2 is equal to 4 plus J6. So solve natin yung Z1 over Z2 and Z1 over, 1 over Z1. So first, letter A, so that is Z1 over Z2. So we have 2 minus J3 divided by 4 plus J6. So getting the conjugate of 4 plus J6, that is 4 minus J6. Multiply natin ang both numerator and denominator. So we have 4 minus J6 over 4 minus J6. Then apply natin yung FOIL method both on the numerator and denominator. We have this. So we have 8 minus J12 minus J12 plus 18J squared over 16 plus 36. And then we have negative 10 minus j24 over 52. And then simplify natin to. So we have negative 5 over 26 minus j 6 over 13. So kung sa calculator, same approach. So input mo lang yung ating complex number. And then 1 over z1 pa pala. So that is 1 over 2 minus j3. And then getting the conjugate of 2 minus j3. So that is, ang conjugate nito, so magiging plus. So we have times 2 plus j3 over 2 plus j3. So that is 2 plus j3 over 4 plus 9. So simplify natin yan. That is 2 over 13 plus j3 over 13. Okay. So natapos na natin yung apat na operations, arithmetic operations ng isang complex number. So proceed tayo pag naka-polar form naman. Okay? Kasi kanina naka-rectangular form. Ngayon naman in polar form. So pag naka-polar form, so para makapag-add ka or subtract numbers in complex form, so we need to convert muna yung complex number to rectangular form. Kasi hindi ka pwedeng mag-add or subtract in polar form. So kailangan convert mo muna yung polar form to rectangular form. And then you add or subtract the corresponding real and imaginary parts. So example natin dito, ito, we have 3 bar angle 30 degrees minus the quantity 6 minus j2 plus 5 bar angle negative 20. So, ito ang gagawin natin. Kinonvert natin yung 3 bar angle 30 degrees. So, that is 2.598 plus j 1.5. And then, convert natin yung 5 bar angle negative 20. So, that is 4.698 minus j 1.71. So, add natin real part to real part and then imaginary to imaginary parts. So, makukuha natin sagot is 1.296 plus j 1.79. Okay? So, kung sa calculator natin ulit, i-input lang natin yung tanong. Okay? So, we have, lagyan natin ng parenthesis. So, we have the parenthesis open. So, 3. O yung bar angle nandito sa may negative. Shift. Then, press the negative. So, para lumabas yung bar angle. So, 30. Take note natin. Hindi ako makalimutan. Nakita ko naka-region yung calculator. Pero itong ano natin, naka-degrees, di ba? Kasi this is polar form. So, gawin natin munang naka-degree yung ating setup. So, we have shift setup. So, degree natin ha. Ayan. So, 3 bar angle 30 minus 6 minus j2 or that is 2i plus, again, parenthesis tayo. Pwede siya maghalo-halo. 5 bar angle negative 20 degrees. So, input mo lang yan and then yan na yung sagot. We have 1.2965 plus 1.789899. So, ito na yung ating answer. Para naman kung ano, multiplication and division. So kapag multiplication and division in polar form, this is, pwede to, yung ating division and multiplication. So to do this, so if you have Z1 is equal to R1 bar angle theta 1 and Z2 is equal to R2 bar angle theta 2, so multiplication, that is, multiply mo lang yung modulus. Okay? Multiply mo lang ang modulus. So, R1, R2. Bar angle, yung argument is i-add lang natin. So, we have theta 1 plus theta 2. So, again, we multiply yung ating modulus and then i-add lang yung arguments. Say, for division naman, so, we divide yung ating R or modulus. So, we have R1 over R2. Bar angle, and your arguments are ma-minus natin. So, theta 1 minus theta 2. So, example, we have Z1 is 3 bar angle 30 degrees and Z2 is equal to 5 bar angle negative 20 degrees. So find Z1, Z2, and Z1 over Z2. So Z1, Z2, so we have 3 bar angle 30 times 5 bar angle negative 20. So again, multiply natin yung modulus. So 3 times 5, that is 15. And then 3 plus negative 20, 30 plus negative 20, that is 10. So we have 15 bar angle 10 degrees. For division, ayan naman. So we have this one. So we have 3 over 5. Okay, 3 over 5. Divide lang natin yung, yung R. Bar angle, yung theta is subtract. So we have 30 minus negative 20. So we have 3 over 5, or that is 0.6. Bar angle, so 50 degrees. So kung sa calculator na approach, input lang natin yung ating given and then apply the operation sa calculator. So next, we proceed to powers of complex numbers. So we have ito. So this is De Moivre's theorem. So according sa theorem niya, so we have the quantity cosine theta plus j sine theta raised to n. That is cosine n theta plus j sine n theta. Okay, so ito this is in trigonometric form. So in polar form, this is r bar angle theta raised to n, that is equal to r raised to n bar angle n times your theta. So take note in solving for the complex power of your complex number. So we use the polar form. So kung ang given is rectangular form, we need to convert it to polar form. So may example tayo dito. So simplify 1 plus j raised to 6. So yung 1 plus j, convert natin to polar form. Okay? So convert natin to polar form. Ayan siya. So we have square root of 2 bar angle 45 degrees raised to 6. And then we have your r. So square root of 2 raised to 6 bar angle 6 times 45 degrees. So we have 8 bar angle 270 degrees. So pag dinrawing natin yung 8 bar angle 270 degrees, okay, dinrawing natin yan, yung angle na to, 270, ito yan, 270, nandito, dito, sobrahan yung aking arrow. So this is 270 degrees, okay, or we can say that is negative 90 degrees. So parehas lang yan. Yung 8 bar angle 270 degrees is the same as 8 bar angle negative 90. So itong isa nga lang is nag-travel counterclockwise, yung isa is clockwise. And then, simplifying this, we have negative j8. And then another example is we have, to simplify, j raised to 32 plus j raised to 21 plus j8. Try natin. Pwede sa emulator na to eh. Sa emulator, pwede siya, pero I think sa calculator hindi siya lumalabas eh. Yung sa, talaga eh. Revise mismo talaga. Ito kasi is emulator. So, we simplify this. So, para ma-simplify natin tong given na, given natin, so ang gagawin natin is, di ba may definition tayo? So, we have your j, that is square root of negative 1, di ba? And then therefore, j squared is equal to negative 1. So gawin natin to in terms ng ating j squared. So pakita natin to. Okay? So 32 divided 2, so that is so that yung 32 divided 2 is 16, di ba? So we have j squared raised to 16. And then itong j21 raised to 21, so 21 over 2, that is 10. Pero may remainder 1 ka. So we have j squared raised to 10. And then yung remainder 1, we have times j. So j na lang to. Plus j8, so raised to 8. So we have j 8 over, so yung 8 natin, 8 over 2, we have 4. So j squared raised to 4. And then j squared natin, di ba, is negative 1. So we have to write negative 1. And then negative 1 raised to, ito ay isang even number, di ba? So positive yan. Pag odd number, we have negative as our answer. So this is negative 1 raised to this one. So we have 1 plus ito, negative 1 raised to 10 is 1 times j. So we have j. And then negative 1 raised to 4 is 1. So 1 plus 1 is 2 plus j. So our answer for this is 2 plus j. And then next, proceed tayo sa roots ng complex number. So in finding for the roots of a complex number, again, we use the polar form. And then we have this formula. So W sub k, that is equal to the nth root of r, bar angle theta plus 360k over n. So we have k is equal to 0, 1, 2, and so on up to n minus 1. So yung roots natin, kunyari, we have a third root, di ba? We have 3 roots. And then kapag fourth root yan, we have 4 roots, and so on. And then pag meron kang fifth root, so we have that is 5 roots. Okay? So that is k is equal to 0, that is the first or the principal root. K is equal to 1 is the second root. K is equal to 2 is the third root, and so on. Okay. Proceed tayo on the example. So find the 3 cube roots of 2 plus j 11. So to find for the 3 cube roots of 2 plus j 11, we apply the formula. But first, we convert the given 2 plus j 11 to polar form. So convert natin to polar form. This is 11 plus 80, 11.18 bar angle 79.70. And then the formula, ito, in finding for the root. So this is cube root, diba? So we have 3 roots. So your k is 0, 1, up to 2. And then hence, the 3 roots are as follows. So substitute lang natin substitute lang natin, and then solve natin using the calculator. So we have 2.236 bar angle 26.57, and then W1, the second root is 2.236 bar angle 146.57, and the third root is 2.236 bar angle negative 93.43 degrees. So next, proceed tayo on logarithmic functions of complex numbers. So sa logarithmic function, gagamitin natin yung exponential form naman ng ating complex number. So logarithm of z is, again, we use the exponential form. So r e raised to j theta. So we have logarithm of r plus j theta, logarithm of e. Excuse. And then ln of z, that is ln of RE raised to j theta, that is ln of r plus j theta times ln of e. So solve tayo. Oops. Ayan. So evaluate logarithm of 3 plus j4. So to evaluate the logarithm of 3 plus j4, so we convert 3 plus j4 to exponential form. So we have 5e raised to j 0.9273. And then we solve applying the formula. So we have logarithm of 5 plus j times 0.9273 logarithm of e. So our answer is 0.6990 plus j 0.4027. So try ko nga kung kaya niya dito. So 3 plus 4i. Yun na. Ito na yon. So kapag in-input mo to direkta on your calculator, so we have logarithm of 3 plus 4i, di ba? Input mo to sa calculator, this is math error. Same with ln natin. So ln ng 3 plus 4i, that is also math error. So we apply this formula, di ba? So na-convert natin to exponential form. So we have logarithm of 5, di ba? So input lang natin itong formula. So kailangan nyo talagang tandaan yung formula for this one. So we have I 0.9273 9273 logarithm of E. Ayun. Bago pa lang lalabas yung sagot natin. Okay. And then next is evaluate ln of 3 minus j1. So convert muna natin yung 3 minus j1. So that is this one. 3.1623 e raised to negative j 0.3218. And then ln of 3 minus j1, that is ln of 3.1623 plus j times negative 0.3218 ln of e. ln of e, that is equal to 1. Okay? Itong ln of e is equal to 1. So we now have to solve ln of 3.1623. So that is 1.1513 minus j 0.3218. Okay? So yan yung ating logarithmic function. So dito sa part na to, kailangan memorize natin yung ating magiging formula to solve for logarithm and natural logarithm ng isang complex number. Next, we proceed to the trigonometric functions of complex number. So, ang ginagamit natin dito for trigonometric functions is the concept of sum and difference of two angles. And then, dapat dito, ang given natin ay naka-rectangular form. So, in rectangular form, di ba? So, using the concept of sum and difference of two angles, sin, cos, cosine, di ba? If you can recall, sin, cos, cosine. So, we have sin x, cosine jy, plus or minus cosine x, sin jy. Okay? So, sin, cos, cosine. And then for cosine, cos, cosine, sin. And then baliktad yung ating operator. So kung x plus jy, so we have negative. And then kung x minus jy, we have positive. So cosine of x plus minus jy, that is cosine x, cosine jy, plus or minus sin x, sin jy. Okay? Kaya lang, itong cosine jy, kapag in-input sa calculator, let's say 4i, di ba? In-input sa calculator yan, that is math error. Okay? So, hindi natin ito masasolve. Same with yung ating sign, let's say 3 plus 4i. So, that is also math error. Okay? So, meron tayong relationships between trigonometric and hyperbolic function. So, we can use this to simplify this ating equation na nandito. So, our relationship between these two, between trigonometric and hyperbolic. So, we have sin jy, okay? That is j hyperbolic sine of y. And your cosine jy is hyperbolic cosine of y. Substitute natin to dito. So, may mga j na nandito. So, therefore, we have sin x plus minus jy is equal to sin x cos y plus or minus j cos x sin y. And then, cosine of x plus or minus jy. So, we have cos x cos y minus or plus j sin x sin y. Okay? So, ito yung ating magiging equations for solving trigonometric functions. Kaya lang, ito ay sine and cosine pa lang. So, to solve, kung meron tayong bibigay na tangent, cotangent, secant, tsaka cosecant, we can use trigonometric yung ating mga function, identities natin. So, tangent of z is sin z over cosine z. Cotangent z is equal to 1 over tangent z, or that is cosine z over sine z. Then secant z is 1 over cosine z, and cosecant of z is 1 over sine z. So, ito lang yung ating tatandaan. This formula and these functions. So, solve tayo. Evaluate cosine 1 plus j2. So, from the formula, so we have cos, sin, sinh. So, gawin ko lang ganon para medyo tuloy-tuloy tayo. Cos, sin, sinh. So, sinh lang basta natin dito ha. So ito, cos 1, then cos 2, minus j sin 1, sinh 2. So, input natin sa calculator to. So, ang sagot natin is 2.0327 minus j 3.0519. So input natin sa calculator. So we have cosine 1 and then cos. So we have height, ito, and then cos 2 minus yung ating I or yung ating j, and then sine 1, yung ating hyperbolic sine or sinh, height 1, so 2. Ang ating sagot, we have, oh, iba ang sagot natin. So, tatandaan ninyo kapag ganito, dapat kayo ay naka-radian. So, when evaluating trigonometric functions, okay? So, pag nag-evaluate tayo ng trigonometric function, dapat kayo ay naka-radian. So, lagi nyo check to. Kasi ito ang kadalasan talaga nagiging mistake. Okay? So, dapat naka-radian, and then input natin yan, and then equals. So, we now have the same answer. Okay? So, dapat naka-radian kayo. And then the next is evaluate cosecant of 1 plus j2. So, since your cosecant is 1 over sine, z, di ba? So, kunin natin yung sine. So, we have sine 1 cos 2 plus j cos 1 sinh 2. So, that is 3.1658 plus j 1.9596. And then, getting cosecant, that is the inverse of your sine. Okay, so we have 1 over 3.1658 plus j 1.9596. So therefore, cosecant of 1 plus j2 is negative, 0.2284 minus j 0.1414. Okay, so kung input nyo sa calculator to, make sure na kayo ay naka-radians. Next is hyperbolic functions tayo ng isang complex number. So again, using the sum concept ng sum and difference. So ito again. Pero this is sinh, cos, sinh. And then cos, sinh. And then ito, di ba? Again, we have the relationships between the two. So we have sinh jy is equal to j sin y, and cos jy is cos y. Okay. And then therefore, we have sinh of x plus or minus jy is equal to sinh x cosine y plus or minus j cos x sin y. And then for cosine, x plus or minus jy, that is cos x cos y plus or minus j sinh x sin y. Okay. And then again, for tangent, hyperbolic cotangent, hyperbolic secant, and hyperbolic cosecant, we use again these definitions. Okay? And then example tayo ulit. So evaluate sinh of 2 plus j. So diretso lang. So we have sinh 2 cos 1. Itong j is 1, di ba? And then plus j cos 2 sin 1. So we have 1.9596 plus j 1 at j 3.1658. And then the next is we evaluate hyperbolic cotangent of 1 plus j2. So yung ating hyperbolic cotangent is that is cos over sinh. So we have to evaluate first for the cosine, hyperbolic cosine of 1 plus j2. So we have negative 0.6421 plus j 1.0686. And then for sinh 1 plus j2, that is negative 0.4891 plus j 1.4031. So by definition, so your hyperbolic cotangent of 1 plus j2 is cos 1 plus j2 over sinh 1 plus j2. So ito, divide natin. Pwede na ito sa calculator. So our answer is 0.8213 plus j 0.1713. So take note again, pag nag-input sa calculator, kayo ay dapat naka-radian. Okay, so this is the last part for complex number, part 1. So inverse trigonometric and hyperbolic functions of complex numbers. So we have the different formulas for the inverse trigonometric functions and for inverse hyperbolic functions. So medyo medyo maano yung formula niya, medyo maano siya memorizein. medyo madugo siya memorizing. So, these are the formulas for our inverse, trigonometric, and hyperbolic functions. So, ito yung ating formula. Gagamitin natin to in solving for this. So, try natin mag-solve. So, ito yung formulas natin, ha? So, papakita ko rin to sa examples. So, example tayo, I evaluate the arc sine of 1 plus j2. So, to evaluate, ayan, medyo matrabaho lang to yung pag-evaluate ng mga inverse, trigonometric, and hyperbolic functions. Matrabaho to. Kasi ito yung formula natin, di ba, for sine. So, we have negative j ln of jz plus the square root of 1 minus z squared. Medyo matrabaho lang siya i-compute. Kasi ito, kunin natin itong sa loob muna. So, 1 plus j2 squared is negative 3 plus j4. So, that is using the concept on powers of complex numbers. And then, ito, operate ang mga arithmetic. Okay? And then you have 4 minus j4. And then, square root mo yan, that is roots of complex numbers. So, pinagsama-sama dito yung concepts to solve for arc sine. And then, ito na, arithmetic again. So, we have real to real part, and then imaginary to imaginary part. So, ito. And then, you get the ln of this. So, that is concept ng ln naman, logarithm. Ayan naman siya. And then, we multiply it by negative j. So, our answer is 0.4269 plus j, 1.5285. So, matrabaho to. And then, another example is this one. Ito, hyperbolic arc, hyperbolic tangent. So, matrabaho din to. Halo-halo na yung concepts, di ba? So, may share lang ako na technique. Ito is 1 plus j2. Ito naman ay solve for the, ito, 1 minus j2. Inverse hyperbolic tangent niya. Okay? May choices pag sa board exam. Diba? May choices pag sa board exam. Okay? Dito na walang choices pag sa board exam. So, para madali, on your board exam, diba? So, gagamitin natin yung hyperbolic tangent na definition of x plus jy, which is this one. Okay? So, we have sinh x cos y plus j cos x sin y over cos x cos y plus j sinh x sin y. So, ang gagawin natin, yung choices, yung ating ilalagay dito. Okay? Yung choices natin. So, letter A, 1.4142 minus j, 1.178. So, pag input sa calculator yan, so, gawin natin itong definition. Kita mo na mas matrabaho ito. 1, 2, 3, 4. 1, 2, 3, 4. So, mahaba-habang input, di ba? So, ito pala yon. Para mapadali, sinh, so 1, x. Ito yung input natin yung mahaba. Kaya, ang input natin is yung variables. Cosine y, medyo matagal lang magpindot-pindot dito, plus yung I, cos, so hype 2, and then that is x, alpha x, sine y, okay, over, itong sa baba, cos, ayan, cos x, o kung, di ba, kung isa-sign nyo to na input yung 4, tapos number nilagay nyo, that is time consuming. So, itong gawin natin. So, cos y, and then plus, yung j natin is I, sinh, hype 1, x, and then sine y. Ayan, gagamitin natin yung calc function again. So, calc, ayan, and then y, that is the value. Ayan, lumabas. So, we have 1.0833 minus j 0.0908, or that is 88. So, kung mapansin ninyo, itong 1.0833 minus j 0.0909, ito dapat yung tanong. Okay. Kaya lang yung sa tanong is 1 minus j2. So, this is not our answer. Letter A. Hindi ito ang sagot. Hindi ito ang sagot natin. Okay? O, letter B. So, hindi natin kailangan mag-input ng isa-isa, di ba? So, use the calc. So, that is 0.1732. And then, negative 1.178. So, okay. Equals natin. So we have 0.999 minus J0, 1.9999. Okay? So yung ito, 0.993 minus J 1.999. Okay, that is approximately equal to 1 minus J2. So this is our, ito yung tanong natin, 1 minus J2. So this is our answer. Ito. Okay? So pag tinry natin yung iba, C and D, so ito siya. Hindi pa rin siya. So we have 0.333 minus J 0.9432. So hindi ito. So this is not our answer. And then for letter D, we have 0.9931 plus J 0.1178. So hindi pa rin ito. Okay? So our answer for this is letter B. So yun yung ating hack pag ano na, 'di ba? Pag ganito, inverse hyperbolic tangent. Kasi kapag solve natin siya mano-mano, mahaba. 'Di ba? Kung nakita nyo, apply ka ng roots, apply ka ng arithmetic, apply ka ng ln, 'di ba? So, may power, so matrabaho siya. So pag board exam, you can use yung ating calculator technique. Okay? And then remember, dapat kayo ay naka-radian yung inyong calculator. Kasi pag hindi, wala kayong mahanap na tamang sagot. Okay? Sige. So this is end of part 1. So punta tayo sa part 2. So part 2, that is Laplace transform. So kung sa Advanced Engineering Mathematics na course ko, pag sa akin, mahaba ito. Meron pa solving IVPs or initial value problems, and then solving systems of ODEs, and then may application pa yan. Pero for board exam purposes and since lacking tayo sa oras, so yung basic lang ng Laplace muna. Okay? Ito lang din naman kasi yung sa board usually. We have Laplace transforms, inverse Laplace transforms, and ito yung solving inverse Laplace transforms using partial fraction expansion. So for introduction, so Laplace transform, that is a powerful method in solving linear ordinary differential equations or ODEs and corresponding initial value problems, as well as systems of ODEs arising in engineering. Okay, so every sem ko na lang itong define. Okay, so definition ng isang Laplace transform. So if your f of t, so is a function defined for all t is greater than or equal to 0. So the Laplace transform of that is the integral of f of t times e raised to negative st from t is equal to 0 up to infinity. So it is a function of s, that is f of s, and denoted by your Laplace transform of f. So itong nandito na symbol, this is the symbol or for the Laplace operator. Okay? Itong script ng letter L na to. So this is the Laplace operator. So mathematically, your Laplace transform of f of t is f of s, that is the integral of e raised to negative st times f of t dt with your limits from 0 to infinity. So try natin mag-solve ng isang basic na Laplace transform. So we have f of t is equal to 1, where your t is greater than or equal to 0. Okay? So ito, apply natin yung formula natin, di ba? So substitute natin yung f of t, which is 1. Ito na siya. And then your limits is from 0 to infinity. And then this is improper integral. Okay? Ito, this is improper integral since we have 0 to infinity as your limits. So para ma-solve natin to, we use the concept of limits. Okay? So ang concept ng limits is we have now the limit of the integral of your e raised to negative st times 1 dt from your limits from 0 to n with your n approaches infinity. So para ma-solve natin to. Okay? And then bibilisan ko na. So that is integral. Take note, your s, i-treat natin to as constant. So your s in here, that is your complex frequency. Okay? Complex frequency, yung t is time. So we consider this as constant since we are integrating with respect to t. Since this is dt. So we have integral. So we have negative e raised to negative st over s. Okay? And then applying your tawag dyan, rule sa definite integrals. So we have the upper limit minus the lower limit. So substitute natin. So we have negative e raised to negative sn over s plus e raised to 0 over s. So since your n approaches infinity, itong negative e raised to negative sn, this will become, that will be 0. Okay, this is 0. So therefore, and then itong 1 naman, itong e raised to 0, sabi ko kagad, that is 1. Okay? So therefore, your f of s, or Laplace transform of 1, is 1 over s. So that is for s is equal to, that is, your s must be greater than 0. Okay? So kung ganito lagi ang Laplace transform, i-integrate mo, and then matrabaho siya. So to simplify things, we have na-derive na table of Laplace transform. So, sa board exam noon, memorize ko ito. Okay? And then since I'm teaching the subject, memorize ko pa rin ito siya hanggang ngayon. So ito, we have 12 formulas in here. Okay? So we have 12 formulas. We have basic formulas. We have for 1, t squared, t raised to n, e raised to 80, t raised to n, e raised to 80. And then for the trigonometric functions, for cosine and sine, and then for cos and sinh. Okay? So these are our table of Laplace transform. So, ang ginawa ko dito ng board exam, since memorize ko to, ito yung aking ginamit. So, sa board exam naman, ay yung mga simple lang naman ng mga functions yung lumalabas kadalasan. And then, discuss ko na rin yung ating linearity of Laplace transforms. So, ito, first property ng linearity is if you have a sum or difference of several functions, you can separate them. So we have Laplace transform of f of 1 plus or minus Laplace transform of f2. So pinaghiwalay natin yan kapag plus or minus. Okay? Yung ating operator. And then, pag may constant c naman, okay? So we have the Laplace transform of c times f. So we can, pwede rin ilabas yung c. So we have c times the Laplace transform of f. Okay? So kung gusto nyo ng proof nito, i-prove natin to, we can use the integral operator. Then sa integral naman, di ba, nilalabas yung constant. So same with Laplace transform. You can, pwedeng ilabas yung ating constant, which is c. And then, ito ang kadalasang mali ng estudyante natin. Kaya, ginawa ko na itong, nilagay ko na itong third rule. Okay? Ito kasi ang kadalasang mali. So, ang kadalasang mali ng ating estudyante is, ang ginagawa nila, pag mayroong product ng several functions, di ba? Meron dyan na Laplace transform of f1 times f2. Ang ginagawa ng estudyante is pinaghihiwalay pa rin. Okay? So, pinaghihiwalay pa rin nila. So, we have Laplace transform of f1 times Laplace transform of f2. So, hindi ito equal, ha? So, we apply only yung pinaghihiwalay natin kapag plus or minus. So, hindi pwede pag multiplication. So, ito yung kadalasan nagiging mali ng students natin. So, hindi yan equal kapag multiplication. Okay? So, example tayo for linearity. So, determine the Laplace transform of 7 plus 3e raised to 5t minus 6 sine 2t. Okay? So, by linearity property, we have this. Laplace transform of 7 plus Laplace transform of 3e raised to 5t minus Laplace transform of 6 sine 2t. And then, pwedeng ilabas yung constant. So, we have this. And then, ito. So, 7, Laplace transform of 1. So, using formula number 1 dun sa table. So, this is 1 over s. And then, itong Laplace transform ng e raised to 5t, formula number 5. So, we have 1 over s minus 5. And then, yung Laplace transform ng sine 2t, formula number 8. So, we have 2 over s squared plus 2 squared. And then, distribute natin yung constants. So, our answer is 7s over s plus 3 over s minus 5 minus 12 over s squared plus 4. Okay, so ito yung ating answer. Okay? So, yung ibang example, sama ko na lang sa slides and then skip pa natin. So, medyo Marami pa tayong discuss kasi meron pa tayong part 3. So, we proceed to inverse Laplace transform. So, inverse, kabaliktaran lang. So, the function f, ang given is the function f of s. And then, the function f of t is the inverse Laplace transform of f of s. And that includes the notation, f is the inverse Laplace transform of f na malaki. So, kasi ito, yung notation natin, di ba, ang given is f of t. And then, kapag kinuha mo na yung Laplace transform niyan, that is now capital letter F. And then that is in terms of S. So that is now F of S with your F capital na siya, capital letter. And then kapag baliktad, so we have the given F of S. So malaki yung F. So kunin mo yung inverse ng Laplace transform. So babalik tayo sa F of T. Okay? So the symbol that this one, this is your inverse Laplace transform operator. And that is also a linear operator, just like your Laplace operator. So again, we can use the Laplace transform table to solve for the inverse Laplace transform. Okay. So example for this one, find for the inverse Laplace transform of the following functions. Siguro, ito, we have 3. So from this 3, first, ito, Laplace transform of inverse Laplace transform, of 2 over s cubed. So ito, nandun to sa formula number 3. So sa formula number 3, so we have t squared, di ba, on your left side. And then ang Laplace transform yan is 2 over s cubed. So nasa table yan. So nakita natin 2 over s cubed, so same siya. So therefore, the inverse Laplace transform is t squared. Okay? Okay. And then the next, we have the inverse Laplace transform of 3 over s squared plus 9. So kung nasa table kayo titingin, so this is formula number 8. Okay? Formula number 8 doon sa table. So kung makita nyo doon, we have sine omega t. And then yung sa kabila niya, nakalagay yung ating f of s is omega over s squared plus omega squared. Okay? So itong 9, that is 3 squared. Okay? So same yung so same na siya yung omega natin. So we have 3 sa taas and then 3 squared. So your omega is 3. So we have our answer sine 3t. Okay? And then for this one, the inverse Laplace transform of s minus 1 over s squared minus 2s plus 5. Kung titignan sa table, wala tayong gantong form. So walang gantong form sa Laplace transform table natin. So para ma-solve natin to, so we can use completing the square. Okay? So completing the square. So we have getting s squared plus bs plus c, di ba? So to complete the square, kinukuha natin yung kasama ng s, so yung b, di ba? Kukuha natin yung b, so we divide it by 2 and then square natin yan. Okay? So ang given is na ito, s squared sa denominator, s squared minus 2s plus 5. So that is s squared minus 2s plus 5, di ba? Kunin natin yung negative 2. Take note, kasama ang negative, di ba? So we have negative 2 over 2 squared. So this is negative 1. So therefore, this is 1. So gawin natin, so we have s squared minus 2s. Hiwalay natin itong 5. Ito siya. So, plus tayo ng 1 dito. Then, i-parenthesis natin. Sa kabila, mag-minus tayo ng 1. So, pag nag-add ka rito, so, siyempre sa kabila, you need to subtract. And then, kung mapansin nyo dito, this is now, yung s squared minus 2s plus 1, this is now a perfect square. Okay? So, that is s minus 1 squared. Ito, perfect square na to ngayon. Okay? And then, looking at the table, this is formula number 11. Okay? So, that is e raised to 80 cosine omega t. So, that is s minus a over the quantity s minus a squared plus omega squared. Okay? So from this, okay, yung a natin is 1, okay? And then yung omega is 2. So therefore, our answer for the letter C is e raised to 1t, or simply e raised to t, and then cosine 2t, since your 2 is our omega. So ang concept natin for inverse Laplace transform, meron din tayong gagamiting completing the square. O in-abbreviate ko yan na CTS, completing the square. Okay? And then also linearity can be applied on inverse transform. So same concept lang for kung kanina, 'di ba, yung sa linearity ng Laplace transform. So pag sum and difference, so kaya tingin ihiwalay yan, and then pag constant ilabas din natin. Okay? So that is the same concept. So for example, isa lang siguro kunin natin or dalawa. So A and B, kunin natin yung A and B. So letter A, we have to determine the inverse Laplace transform of 5 over 6 minus s minus 6 minus 6s over s squared plus 9 plus 3 over 2s squared plus 8s plus 10. And then letter B tayo, 2s squared plus s over s to the fourth power. So itong sa C, nasa slides naman natin. Bibigay ko yung copy. Okay, so letter A, makalabas ka agad. Okay, so for letter A, so we have the inverse Laplace transform of 5 over s minus 6. Minus 6s over s squared plus 9 plus 3 over 2s squared plus 8s plus 10. So by linearity, hiwalay natin yung tatlong functions, and then ilabas natin yung constant, and 5, 6, tsaka yung 3. So we have, diretso na to. So we have 5 inverse Laplace transform of 1 over s minus 6 minus 6, nalabas na yung 6. Inverse Laplace transform of s over s squared plus 9 plus, mamaya na to. Kasi ito, pag nilabas natin to, okay, yung third, doon tayo sa third function. So sa third function, nilabas natin yung 3. So that is the inverse Laplace transform of 1 over 2s squared plus 8s plus 10. And then ang ginawa natin, since common yung 2, we can factor that out. So we have the 3 inverse Laplace transform of 1. We can factor out 2. So we have 2 times s squared plus 4s plus 5. So, and then labas natin yung 2. Okay? So we now have 3 halves. So ito na siya. 3 halves, inverse Laplace transform of 1 over s squared plus 4s plus 5. Okay? And then, itong denominator ng ating third term, okay, ito. Apply tayo ulit ng completing the square since wala tayong gantong form on your Laplace transform table. Okay? Apply natin yung ating completing the square, CTS. So, again, by CTS, so s squared plus 4s plus 5. Kunin natin yung 4. Okay, so 4 over 2 squared. Ayan, no? So, 4 over 2 is 2 squared. 2 squared is 4. So, s squared plus 4s. So, yung 5 dito nilagay. And then, dito is 4, di ba? So, plus 4. And then, sa kabila, minus 4. And then, we apply, since this is a perfect square, so that is s plus 2 squared plus 5 minus 4 is 1. So, ito na yon. And then, itong 1 over s minus 6, formula number 5. Ito is formula number 7. And this is formula number, may s plus 2 eh. So, this is formula number 11. Okay, so apply natin yon. So, our answer is 5 e raised to 6t minus 6 cosine 3t plus 3 halves e raised to negative 2t cosine t. And then there is another example. So we have the inverse Laplace transform of 2s squared plus s over s to the fourth power. So by linearity, so we have 2s squared over s to the fourth. Okay, diretso na kagad dito. So, di ba, we have 2s squared plus s over s to the fourth. So, linearity property, so we now have 2s squared over s to the fourth plus s over s to the fourth. So, simplify natin to. So, we have 2 over s squared, ito, and then s over s to the fourth power, that is 1 over s cubed. Okay? Then, apply natin yung linearity properties. So, we have 2 inverse Laplace transform of 1 over s squared plus ito, baka magtaka kayo bakit may 1/2. So, from the second term, diba, inverse Laplace transform of 1 over s cubed. Sa ating table, this is formula number, again, number 3. Formula number 3. So, formula number 3, we have t squared. So, ang Laplace transform yan is 2. Okay? Eraser tayo. So, this is 2. Ayan. So, this is 2 over s cubed. Okay? 2 over s cubed. Pero yung form na nandito is 1 over s cubed. Okay? So, ang gagawin natin sa 1 over s cubed, mag-multiply tayo ng 2 over 2. Okay? So, para maging, okay, lagay ko yung inverse operator. So, multiply tayo ng 2 over 2. So, same pa rin yan. We have 1 over s cubed. Kaya lang, ang ilabas natin dito, yung over 2. Or ito, di ba? Yung over 2 yung ilabas natin. So, we now have, lagay natin dito ha. So, 1/2 inverse Laplace transform. Naiwan yung 2 sa numerator. So, we have 2 over s cubed. So, meron na tayong kaparehas na form sa table. Ito, di ba? And then, our answer is 2t plus 1/2 t squared. Okay? So, ito, inverse Laplace transform using partial fractions expansion. Meron tayong tatlong case. So, ito is ginagamit natin kapag yung degree ng P is less than the degree of Q. So, ginagamit natin yung, sabi nito sa note, the inverse Laplace transform of a fraction, is often best found by expressing it as its partial fraction and finding the inverse Laplace transform of this. So, parang sa integral nyo rin, di ba, meron din doong application ng partial fraction to solve rational functions, di ba? So, dito rin sa inverse Laplace transform, we can apply ating partial fraction expansion since integral operator naman to. We have 3 cases, non-repeated linear factors. Ito siya. So, from the given, so we now have the partial fraction expansion is this. And then the case 2 is not repeated linear factors. So kapag repeated yung ating linear factor, so ito naman yung ating form for the partial fraction expansion. And for case 3, quadratic factors, medyo mahaba siya. So ito yung ating form for the partial fraction expansion. So for example, determine the inverse Laplace transform of this one. 3s squared plus 6s plus 2 over s cubed plus 3s squared plus 2s. Okay? So, kailangan nating malaman, okay? Sabi natin dito, sabi natin pala doon sa kanina, na parang namali yung banggit ko. Parang nabanggit ko kanina, mataas yung value ng, yung degree ng P. Baliktad. Mababa yung value ng P, yung ating numerator. So, dapat, so we can use partial fraction once na mas mataas yung degree ng Q or ng ating denominator. So in this case, itong sa denominator is s cubed or that is third degree, while yung ating numerator is second degree. So we can use partial fraction expansion. So itong s cubed plus 3s plus 3s squared plus 2s. So ito ay ating i-factor. So, pag pinactor natin yan, so, di ba, s cubed plus 3s squared plus 2s, okay? So, common yung s. So, we have s times s squared plus 3s plus 2. And then, ayan, no? We can factor this quadratic. quadratic, di ba? Quadratic ito. So we have S times, okay? Gantuin natin, di ba? So S, S. So mag-isip ka ng number. So since plus plus yan, so plus tsaka plus. Isip ka ng number na kapag i-multiply mo is 2, pag in-add is 3. So those two numbers are 2 and 1. So pag in-add mo to is 3, multiply is 2. Okay? So we have S times S plus 2 times S plus 1. And then this is case number 1. Okay, case number 1. Okay, that is case number 1. So we have A over S plus B over S plus 2 plus C over S plus 1. And then apply natin yung concepts on partial fraction to solve for this constants ABC. So masosolve natin dyan, ang A natin is 1, ang B. So pag nasolve natin to, so you can solve it. So your A is 1, nakataon na pare-pareha sila, B is 1, and C is equal to 1. Okay? So, and then now your f of S is now 1 over S plus 1, that is your B, over S plus 2 plus 1, yung C natin, over S plus 1. And then applying inverse Laplace transform for your f of S, makuha mo yung f of t. So we have, this is formula number 1, formula number 5, yung second and third terms natin. So we have 1 plus e raised to negative 2t plus e raised to negative t. Okay? So that is our inverse Laplace transform. So ito namang isa, second example natin, is second case. So we have naka-factor na to. So we have s minus 1 squared times s plus 3. So this is case number 2. Meron kang repeated. And then meron ka rin isa dito na distinct, di ba? So ang ating partial fraction expansion for this one is we have a over s minus 1 plus b, we have over s minus 1 squared plus itong s plus 3, so we have c over s plus 3. And then pag sinolve natin to, so we have your a is 2. Pag sinolve natin to, using partial fraction concept, your a is 2, your b is 3, and your c is negative 1. Okay? So, we now have 2, yung ating a over s minus 1, plus 3, yung ating b, over s minus 1 squared, minus 1 over s plus 3. So, minus na yan kasi we have your c is negative 1. And then, we apply inverse Laplace transform. So, formula number 5, this is formula number 6, and again, number 5. So, we have 2 e raised to t plus 3t e raised to t minus e raised to negative 3t. Okay? So, yan yung ating pag-solve ng ating in Laplace transform, and ito is inverse Laplace transform. Okay? So, ito yung ating discussion for this part. So, on the last part of the session, we will discuss matrices and vectors. Okay? So, sa part na to, dito marami-rami ring calculator techniques. Okay? So, let's proceed. So, introduction. So, your matrix is a rectangular collection of variables and scalars contained within a set of square or round brackets, which consists of m rows and n rows. So, ang term na matrix ay introduce ni English mathematician na si James Joseph Sylvester in 1850. So, matagal-tagal na yung ating matrices. So, maraming application ng matrices. Sa field ng EE, napakarami from, ano ba ito? So, pag-solve ng, di ba, kung maalala niyo sa pag-solve natin sa mga network theorems, you can apply yung ating determinants to solve for unknown variables, di ba? For, kunyari, solve tayo ng I1, I2, and I3, di ba? Kung maalala niyo sa circuits. So, that's another application. And then sa power systems, meron ditong application yung matrices. Okay? So, ang size ng matrix is determined from the number of rows and columns. So, ang basa natin doon is number of rows by the number of columns. So, if we are given this So, ang number of rows, we have 2 rows and then 3 columns. So, this is a 2 by 3 matrix. And then ito, we have 2 rows and 2 columns. So, this is 2 by 2 matrix. Okay? And then another, meron pa pala dito. So, we have 3 rows and then 1 column. So, this is a 3 by 1 matrix. And then we have, on this example, 3 column, 3 rows, and then 2 matrix na tuloy, 2 columns. So this is 3 by 2 matrix. So first, discuss natin yung doon tayo sa algebraic operations or arithmetic operations. Addition and subtraction of matrices. So addition or subtraction of two matrices can be accomplished by adding or subtracting the corresponding entries of two matrices which have the same shape. So for example, ito, we add this matrix A and matrix B. So this is, add natin yung corresponding entries. So 1 plus 3, so ayan, 4 plus 0, and then 1 plus 2, so and so on. So we add the same, okay, pare-parehas, same, yung kanyang corresponding entry sa kabila. So add mo yon. So we have our answer, ito yung ating answer. So we have 4, 4, 3, 9, 6, 12, tsaka 6, 1, 5 as elements ng ating matrix. So sa calculator, like sa calculator, this is mode matrix 6, okay? And then you input the matrix. So matrix A, 1, and then the size, 3 by 3. So input natin, 1, 4, 1, 7, 1, 6, negative 3, 0, and 4. Okay? And then pag na-input mo yan, you press AC. Huwag kayong mag-alala, hindi mawawala yan. And then, to input another matrix, so shift, matrix 4, and then, ito, this one, dim, number 1, dim, and then matrix B na tayo, 2, and then the size again is 3 by 3, so number 1. So input natin ulit, 3, 0, 2, 2, 5, 6, 9, 1, 1. Okay? And then, AC mo ulit, hindi mawawala yan. And then, solve natin, so add natin, so shift, matrix, you input, matrix A, 3, plus matrix B, shift matrix B. So we have our answer, yan, 4, 6, 4, 4, 3, 9, 6, 12, 6, 1, 5. Okay? So that is our answer. So yun yung ating calculator technique. Next is multiplication of matrices. Okay, so multiplication of matrix can be done only if the number of columns of the left-hand matrix is equal to the number of rows on the right-hand matrix. Yun ang condition. So kapag hindi ito na-met, yung condition na to, you cannot multiply the two matrices. So multiplication is accomplished by multiplying the elements in each right-hand matrix column, adding the products, and then placing the sum at the intersection point of the involved row and column. Okay? And then, division. So, division is accomplished by multiplying the inverse of the denominator matrix. So, later, discuss natin yung inverse. So, for the meantime, dito muna tayo sa multiplication, magpo-focus. So, for example, sa dito, ito, if your matrix A is 2, 3, 3, 10, and your B is 1, 3, 5, negative 2, we find the product of A and B, matrix A and B. So, ang sabi natin, di ba? Sabi natin doon, dapat equal yung number of columns ng left hand sa number of rows sa right hand. Okay? So, sa left hand, we have 2 by 2 matrix. And then sa right hand, we have 2 by 2 matrix also. So, equal. So, pwedeng i-multiply ito kapag equal yung number of columns ng left hand columns. So, this is, di ba? So, that, ano ba to? Row by column, di ba? Okay? So, equal naman, di ba? So, we have 2 and 2. So, our answer will be 2 by 2 matrix. So, multiply natin. So, we have 2 times 1 And then plus 3 times 5. Ayan to. Yan siya. And then we have 2 times 3 plus 3 times 2. And then 3 times 1 plus 10 plus 5. And then 3 times 3 times 10 minus 10 times negative 2. So our answer is 17, 0, 5, 53 and negative 11. So pwede rin to sa calculator. So input natin yung ating matrix and then you can solve for A and B. So input mo lang doon. And then another example, ito yung input natin ha sa calculator. So we have matrix A that is a 2 by 3 matrix. And then yung ating matrix B is rows is 3. So we have 3 by 1. Okay? So as you can see, equal yung ano natin dito, di ba? Number of column nung left hand sa number of rows nung right hand. O equal to, di ba? Equal to. So our answer is a 2 by 1 matrix. Ayan. So since equal tong 3 ito, di ba? 3 yung number of columns nung sa left hand and then 3 yung number of rows sa right hand. Our answer is 2 by 1 matrix. Okay? So paano to? So we have this one. So 2 times 2 plus 1 times 4 plus 5 times 1. And then sa sunod na element, so we have 1 plus times 2 plus 4 times 4 plus 7 times 1. And then add natin, so we have 13 and 25. So input natin sa calculator, so you can see. So may na-input na tayo kanina, di ba? I-edit lang natin yon. So shift matrix 4 and then use dim, itong number 1. So we have matrix A and then specify the size. So we have 2 by 3, number 4. So we have 2, 1, 5, 1, 4, 7. Okay, again, AC. Hindi mawawala yan. Again, shift 4, 1, matrix B2. And then this is 3 by 1 matrix. Walang, wala man 3 by 1 dito. Ayun, ito, 3 by 1, number 3. Kala ko wala. Ayan. So, 2, 4, 1. Okay, and then AC tayo. And then, we multiply now. Shift matrix A times shift matrix 4, matrix B. So, our answer is 13 tsaka 25. Yung nasa elements natin. Okay? So, yun yung ating calculator technique. Okay? So, input mo lang siya and then you have the answer. And then, this is another example, pero papahanap yung values of x and y. So, multiplication of matrices is applied on this problem. So, we have 3 times x, 3 times x plus 7 times y. Okay? And then 2 times x plus 6 times y. So, that's equal to 2, 2 tsaka 4. Okay, so this is, 2 by 2 matrix, diba? 2 by 2 matrix, and then this is a 2 by 1 matrix. So, equal to. So, our answer is 2 by 1 matrix. So, kaya meron kang 2, 4, diba? So, this is a 2 by 1 matrix. So, ito na siya, 3x plus 7y, and then 2x plus y, 6y, and then ito, 2, 4. So, kunin natin tong element na to. So, 3x plus 7y is equal to 2, and then 2x plus 6y is equal to 4. Okay, and then, para ma-solve natin yung x and y, mga tayong pahirap sa sarili natin. So, to solve that, we use mode equation. So, mode 5, and then, 2 equations, 2 unknowns is number 1. Input natin ng numerical values. 3, 7, 2, 2, 6, 4. So, dapat pag i-input sa calculator, dapat naka-arrange na siya. So, you have x, y, and then equals your constant. Okay, so, ito na siya, equal natin. So, we have negative 4 yung x, and then yung y is 2. Okay, so, yeah, ito yung ating answer. So, we have x is equal to negative 4, and y is equal to 2. Okay. Next, we have other operations on matrices. Medyo marami to. Pero meron din tayong mga techniques. So, first is the transpose of a matrix. So, sa transpose, ayan siya. Your transpose ng isang M by N matrix is formed from the original M by N matrix. So, ang gagawin lang natin is from your ith row, gagawin mo lang siyang ith column. So, transpose mo lang. Yung diagonal dito is unchanged. This is unchanged. Hindi uncharged. This is unchanged. So, hindi na bago yung diagonal natin. Yung ganun. Okay? So, the transpose of a matrix is indicated as A raised to T. So, example, ito. Yung transpose. Yung transpose nitong matrix A na given. So, para makuha yung transpose niyan, so, di ba, yung column, yung row, gagawin natin column. So, ang, ano nito, ang transpose nito, okay, so we have itong, ano di ba, itong row, gawing column. So, we have 1, 6, 9, 2, 3, 4, and then 7, 1, 5. Take note, hindi nagbago yung diagonal. Ito, 1, 3, 5, 1, 3, 5. So, pag nag-transpose ka, hindi mababago yung diagonal. Okay? And then, for the calculator, mayroon naman yan sa calculator, meron yang, input na naman tayo. Meron yan ditong transpose. So, yung transpose natin for that is mode 6, di ba? Matrix. Okay? So, to solve for the transpose, kung nakalimutan nyo yung transpose, di ba? Gagawin nyo. So, you can use itong TRN. So, number 8. So, that is transpose, TRN. Transpose of matrix A. Shift for 3, matrix A. So, we have, yan, 1, 6, ito pala, sa baba. So, 1, 2, 7, 6, 3, 1, 9, 4, 5. Okay? Yeah. Determinant na tayo ng matrix. So, the determinant B is a scalar calculated from a square matrix. The determinant of a matrix is indicated by enclosing the matrix by vertical lines. So, kung yung ating matrix ay, di ba, naka brackets or naka parentheses. Yung determinant, denoted siya or indicated siya by enclosing the matrix by vertical line. Okay, so for example, ito. Okay, so we have 5, negative 9, 7, and negative 6. So to solve for the determinant, we apply yung, di ba, yung mga pababang ganyan, minus yung mga pagando, mga pataas. So we have ito, yung una. So 5 times negative 6. Okay, and then itong pataas, minus itong 7 times negative 9. So we have 33. So sa calculator, input lang natin yan, yung matrix. We do it later. So, next example, ito, 3 by 3 matrix ang given. Evaluate, ito, wala siyang, ano diba, wala siyang nakalagay sa tanong. Sabi lang niya, evaluate. Tapos yan. So, itong sabi dito, pag ganito, diba, we have vertical lines. So, this denotes determinant. So, you need to solve for the determinant of this. Okay, so, to evaluate for the determinant, ang ginagawa natin, sa akin, ginagawa ko, kinakopy ko yung first two. Ito, yung first two na to. Yung first two columns, kinakopy ko. So, we have ito. Diba? Kinakopy ko yan dito sa kasunod. So, para we can apply yung ating concept na yung pababang ganyan, minus yung pataas, verticals. Okay? I mean, diagonal, pababa. So, first, ito, yung mga pababa na diagonal. So, we have 2 times 1 times negative 2. Ito siya. Plus, so plus natin yung kasunod. So, plus negative 1 times 5 times negative 2. Plus 3 times 2 times 3. Ayan. Okay, so, kaya nakapit ko yung first two columns para hindi magbalik-balik ganun. Diba? Kasi kung may isang technique din na yung sa iba, binabalik-balik. So, medyo nakakalito lang siya. Okay? So, ito para dire-diretso yung ating pagkuha ng mga products ng ating para sa determinant natin. And then minus tayo yung mga diagonal pataas. So we have negative 2 times 1 times 3. Ito siya. And then we have 3 times 5 times 2. ito, plus negative 2 times 2 times negative 1. Ayan. And then, you solve that. So, we have determinant is equal to negative 4. So, sa calculator, input natin yan. So, naka-matrix pa rin tayo na mode. So, gagawin natin, matrix mode pa rin. So, shift, matrix, itong 1, dim. Palitan natin yung value ng matrix A, number 1. And then that is 3 by 3 matrix. Input natin yan. Okay. Input natin yung elements ng matrix. And then press AC. Don't worry, hindi ulit mawawala yan. So, okay. And then shift 4. Determinant is 7. Ayan o, det. Determinant. So, 7. Shift matrix. This is matrix A, di ba? So, 3. So, determinant of matrix A is negative 4. O, di ba? Ito na yung sagot natin. We have negative 4. And then, ito, meron tayong solving, meron tayong 4 by 4 matrix. Kasi, ito, yung 4 by 4 matrix, hindi kaya nung, ito, yung ating Casio na to, 570. Hindi siya kaya ng calculator. Kasi ito, hanggang 3 by 3 matrix lang. So, pag 4 by 4 matrix, meron tayong meron akong dalawang method dito. So, first is expansion method. So, sa expansion method, we reduce a 4 by 4 matrix to a 3 by 3 matrix. So, ito siya. So, from a 4 by 4 matrix, so ang ating reduction, so we have D, determinant, is equal to A11 times ito, A22, A23, A24, A32, A33, A34, A42, A43, A44. So, ito na yung formula natin, nasusundan. So, meron kang i-evaluate na 4 na matrices. Okay? You have to evaluate the determinant of these 4 matrices. So, and then, you apply the operation. Expansion method siya. And then, the next is the pivotal method or the pivotal element method. Sa pivotal element method, pipili ka ng isang element dito na ipapivot mo. So hence, that is pivotal element method. You need to choose a pivot point. Okay? That pivot point must be equal to 1. Okay? Pinakalagay dito. So, itong A22 na pinili natin, this must be equal to 1. Okay? And then, that will be the pivot point. Okay? So, 1. Kung hindi 1, kung walang 1, gagawin mo, kunyari, napili mo yung A11, pero ang value niya is 4, di ba? Na gawin mo siyang pivot. I-divide mo muna ng 4. Yung buong ano na yan, yung buong, tawag dyan, buong row, i-divide mo ng 4, yung buong row, so that, para maging 1 na yung pivot mo. And then you apply, apply the pivotal element method. Okay? So, ayun. So, divide mo yung first row. So, you divide this first row by your napiling pivot. Kung hindi siya, 1. Okay? So, ang formula natin for solving the determinant of this 4 by 4 matrix, medyo mas madali ito kasi isa lang ang determinant mo na, isang 3 by 3 matrix lang yung kukunin mo yung determinant niya. So, we have negative 1 raised to I plus j, where your I and j, okay, hindi ko nalagay kasi dito, your I is the number of, yung number of row. Okay? And then yung j is the number of column nung iyong pivot point. Okay? So we have yan, I plus j, and then this one. Ito yung mga elements. Ito, yan. So we have a 3 by 3 matrix. So solve natin para makita nyo. So for example, evaluate this 4 by 4 matrix. So by expansion method, ito siya. So yung problema lang dito, di ba? 2. This is our pivot. Ano bang pivot point dito? Wala palang pivot point ito. So by formula lang pala tayo, no? So by formula, so A11, so we have 2. times ito. So yung 2, negative 2, 3, negative 2, 3, negative 2, 4, negative 4, negative 2, and negative 3. And then minus, yung sunod, 0. And then, pag 0, di ba? So ito, 1, negative 2, 3, 3, 3, negative 2, 4, negative 2, and negative 3. Plus, ito, 1 times, ito yung elements natin, 1, 3, 1, 2, 3, 3, negative 2, negative 2. Niskipan ko to ha. Nakita ko napapansin nyo. Niskipan ko tong nandito para mabuo yung matrix na kukunin natin determinant, di ba? So, 1 ulit, di ba? Skipan ko to pag nagagawa ko ng matrix. Skip natin yung nandito sa column na to. So, we have 1, 2, 3, okay? 3, negative 2, negative 2, and 4, negative 4, negative 3. So, same na rin dito sa kasunod, negative. So, we have negative 1. So, we have, ito na, 1, 2, negative 2, 3, negative 2, 3, 4, negative 4, negative 2. Okay? And then, solve natin kada, ano to, determinant ng 3 by 3 matrix. So, 4 yan. So, we have this. Our answer is 84. Okay? Kung ano naman, kung ang napili niyong method is the pivotal element method. Okay? Pivotal element method. Pipili tayo ng isa, which is equal to 1. May equal to 1 naman dito sa given. Ito, yung ating A. Ayan. Ayan, no? At ito siya yung 1 natin, di ba? Okay. So, by pivotal element method, so this is yung A21, this is A21. Okay? So, this element is located on the second row, first column. So, that is A21. So, we have negative 1 raised to 2 plus 1. And then, ang pagbuo ng elements ng ng matrix na to, so we have, okay, di ba ito? So we have, ito sa taas, di ba? So 0, ito, minus, yung nag-intersect sa kanya, minus 2 times 2. Ayan, di ba? Okay, ito siya. And then for the next element, so 1, ito, minus negative 2, ito, di ba? Times 2. And then the next, negative 1 minus 3 times 2. And then we have negative 2 times 2 times, negative 2 minus 2 times 3. And then 3 minus negative 2 times 3. And then negative 2 minus 3 times 3. And then the next, negative 4 minus 2 times 4. And then negative 2 minus negative 2 times 4. And then last, negative 3 times minus 3 times 4. So, gulo na pagbuo ng ating elements for the 3 by 3 matrix. So, itong kunin mo yung element and then minus mo sa product ng intersection. Ayan, diba? And then, evaluate natin. So, we have this. And then, get the determinant. So, we have negative 1. Okay, so 2 plus 1 is 3. So, negative 1 is to 3. That is negative 1. Then, evaluate the determinant. And then, we got the answer, 84. Okay? So, medyo matrabaho nga lang siya, di ba? So, meron akong i-share na technique for solving 4 by 4 matrix. Kasi yung calculator natin na ginagamit for the board exam ay, tawag dyan, hindi kaya yung 4 by 4 matrix. So, by calculator techniques on a 570 Casio, okay? Ito yung pivot point, di ba? Yung 1, okay? So, drawing tayo ng box, okay? Tawag dyan, horizontally, and then vertically. So, magiging ganyan yung tsura niya. And then, meron tayong isa pang box. Ito naman, itong box na to. Okay? So, paano natin makukuhaan to ng calculator technique? So, ang una kong gagawin is a 3 by 3 matrix. Dito sa green, 3 by 3 matrix na magagawa ko. Hindi lang kasama yung may blue. Okay? Hindi lang kasama tong intersection ng 1, nung ating pivot point. So, ito lang yan. So, ito, 0, 1, negative 1, negative 2, 3, negative 2, tsaka negative 4, negative 2, and negative 3. So, it will be your matrix A. Okay? And then for matrix B, itong vertical, hindi kasama yung pivot point. Okay? So 2, 4. So you have hindi kasama yung pivot point. So 2, 2, and 3. So we have 3 matrices. We input the calculator. Okay? Input sa calculator. So shift, nakamat pa rin tayo. Matrix, dim, 1, matrix A, and then 3 by 3 matrix, number 1. So input natin, 0, 1, negative 1, negative 2, 3, negative 2, negative 4, negative 2, and negative 3. Okay, and then press AC. Input matrix B, shift 4, and then dim 1, matrix B 2, and then that is a 3 by 1 matrix. So number 3. So we have 2, 3, 4, and then matrix C tayo. So shift matrix, dim ulit, 1, 3, and then that is 1 by 3 matrix. 1 by 3. Walang 1 by 3. So, meron ka pang option para bumaba. Okay, go down. So, you have 1 by 3, number 1. Okay, so input 2, negative 2, and 3. Okay, so AC natin yan. So, para ma-solve natin yung determinant, di ba? Ito yung formula natin for solving the determinant. So, we have negative 1, okay, raised to I plus J. So, yung I plus J natin, di ba? This is, again, A21. So, 2 plus 1 is 3. Okay. So, times, okay, determinant, that, shift 4, 7. Okay. And then, matrix A, shift matrix A, 3. Minus shift matrix B times shift matrix C. Yan. So, ayun. So, equals, so we have 84. So, ito yung ating Caltech for solving for solving a 4 by 4 matrix. Okay. So, other operations again, we have the cofactor matrix. So, the cofactor matrix is a matrix formed by replacing each element in the given matrix by its cofactor. And then the classical adjoint, that is a matrix formed from the transposed cofactor matrix with the conventional sign arrangement. The resulting matrix is represented as A sub ADJ, or that is adjoint. And then last is the inverse matrix. So the inverse, A raised to negative 1. Ito yung pag-denote natin for inverse. So that is a matrix such that your A times the inverse of A is equal to I, where your I is a square matrix with the ones along the left to right diagonal and zeros elsewhere. So, solve tayo ng problems involving these 3 other operations. So, this one is find the cofactor matrix of this one. So, kapag cofactor matrix, medyo matrabaho siya. So, ito siya. Oh. Kukunin mo yung cofactor. Ayan. Matrabaho lang ito. So, we have negative 1 raised to I plus j. And then, ito, di ba? Na-cross out ko na to. So, we have negative 4 to 1, 5. So, get the determinant. Then, so on. So, ito naman, for A12, ayan, no, yung 3. So, we have 1 plus 2. And then, ito, 0, 2, 1, 5. So, and so on yan. So, since you have 3 by 3, 9 elements yan. So, kukunin mo yung cofactor ng siyam na elements. So, continue tayo. And then, ayan, hanggang A33 na cofactor. And then, pag nakuha mo na lahat ng cofactors, you can now form the cofactor matrix. So, ito yun, di ba? Negative 22, 2, 4, negative 19, 14, 1. Tapos ito, negative 10, negative 4, and negative 8. Okay. For the cofactor matrix, meron akong Caltech. This one. So, we have to get the transpose of matrix, the inverse of matrix A times the determinant of matrix A. So, try natin. Ito. Input natin yung ating, again, yung ating matrix. So, sa matrix mode tayo. So, edit na lang natin. So, shift 4, dim, we have matrix A. Edit natin yan. So, 3 by 3. So, input natin to, yung ating elements. Okay. Yan siya. And then, AC. And then, so, ang sabi sa, lipat ko to ha. Yan. Ang sabi natin dito, transpose of your matrix, inverse of matrix A times determinant of matrix B. So, para makuha natin yan, so, transpose, shift, 4, TRN, number 8, and then matrix A, inverse. So, matrix A, yung inverse natin nandito, ayan o, yung x raised to negative 1, times determinant of A, determinant, shift 4, 7, and then matrix A again. Matrix A is 3. Ayan. Okay, so pag na-input na natin yan, isa pang parenthesis pala, para sa transpose operator. So, pag na-input natin to, ito yung caltech natin. So, we can get, medyo matagal lang, ayan. So, we have negative 22, 2, 4, negative 19, 14, 1, negative 10, 4, negative 4, and negative 8. So, that is how you get the cofactor gamit yung calculator. So, tandaan nyo lang yung formula natin na to. And then, classical adjoint naman, so ang classical adjoint, di ba nasolve na natin yung cofactor matrix nito, same matrix. So pag nasolve na natin yung ating cofactor, di ba, kukunin mo yung classical adjoint, so gagawin mo lang is transpose mo yung cofactor matrix. So to solve for the classical adjoint, okay, you transpose your cofactor matrix. Okay? So you transpose the cofactor matrix. So you can get this classical adjoint. So transpose mo lang to. So you have negative 22, and then negative 19, negative 10, and so on. So kung sa Caltech naman, di ba kanina doon sa cofactor, meron kang transpose dito, di ba, na nilagay. Same formula. For classical adjoint, wala lang transpose. So, wala lang transpose yung ating formula for the Caltech. So, matrix A raised to negative 1, that is the inverse. And then shift of determinant 7. And then matrix A, yan. So, that is, ayan. So, negative 22, negative 19, negative 10, 2, 14, negative 4, 4, 1, negative 8. So, yun yung ating Caltech naman for classical adjoint. And then, ito sa inverse, we have, ito yung formula natin for inverse. So, we need to get the inverse of matrix A, 4, 5, 2, 3. So, ang ating formula for inverse matrix, so that is 1 over the determinant of matrix A times the adjoint of A. So, pagkuha ng adjoint, di ba, yung kaninang, yung mano-mano, so that is, yun, yung mano-mano natin, mahaba siya. Classical adjoint, kunin mo yung cofactor and then transpose mo, di ba, to get the classical adjoint. And then determinant, okay, so na-discuss na natin yan. So, ayan, this is the classical adjoint. And then this is the determinant of A, 2, ayan. And then you apply the formula. Okay, so, you can get this, 3 halves, negative 5 halves, negative 1, and 2. So, yung pinanggalingan ng mga formula ko for the Caltech, dito siya galing. Okay? Dito lang siya galing. Oops, sorry for that. So, dito lang galing yung ating formula doon sa Caltech, kung mapansin niyo, di ba? So, inverse times determinant of A, so that is the classical adjoint. And then transpose mo, that is the cofactor matrix. So, yun yung, dito siya nanggaling, actually, yung ating formula. So, ano naman ang technique natin for inverse matrix? Paano naman ang technique natin for inverse matrix. So, pag inverse matrix, so input natin yung matrix. So, dim 1, 1. Gawin natin 2 by 2 matrix, 5. So, 4, 5, 2, 3. And then, okay na yan. So, to get the, to get the inverse, so we have matrix A. So, shift 4, 3. And then we have inverse. Ito, yung x raised to negative 1 na button. So, yan lang siya. Matrix A inverse. So, yan yun. And then, you get this. So, we have 3 halves, negative 5 halves, negative 1, and 2. So, ganoon lang kasimple yung Caltech for the inverse matrix. Then, Cramer's rule. Meron ding Caltech dito. So, Cramer's rule is used to solve systems of linear equations using determinants. So, for a system of linear equations, x is equal to dx over d, y is equal to dy over d. That is d sub x and then d sub y. So, your d is the determinant of the coefficient of variables. Your d sub x is the determinant taken from d, replacing the coefficients of x by their corresponding constant terms, leaving all other terms unchanged. Same for dy. So, coefficients naman of y is replaced by their corresponding constant terms, leaving all the other terms unchanged. So, example 1 for Cramer's rule. So, ito ang given natin na equation. And then, solve natin yung matrix, determinant ng matrix D. So, we have, kukunin natin yung constant coefficients ng mga variables. So, 15, negative 4, 8, and 1. So, we have 47, yung determinant. And then, dx, d sub x, papalitan mo yung nasa x, di ba? Ito yung sa x, yung ating first column. Papalitan mo yan ng constant term. Ito nandito sa right side of the equation. So, we have 5, and then negative 4. And then, other terms are unchanged. So, we have negative 4 tsaka 1. So, we have negative 11. And then, dy, papalitan natin yung dito sa second column. So, we have 15, 8, tapos 5, tsaka negative 4. The answer is negative 100. And then, solving for x and y. So, x is dx over d. So, we have negative 11 over 47. And y is negative 100 over 47. So, kung gusto nyo ng Caltech, for this, alam natin, this is 2 equations and 2 unknowns. So, we use mode 5, 1. And then, next example, this is a 3 equations and 3 unknowns. So, same concept. So, D is the yung mga coefficients ng mga variables. So, we have negative 46. And then, for dx, papalitan mo yung first column ng constant na to. Ayan siya. And then, other elements or other terms are unchanged. So, we have negative 92. And for dy, ito namang second column papalitan. So, we have this. And then, others are unchanged. So, we have 46. And then, for dz, so we have to change your third column. So, ito na siya. We have negative 138. So, solving for x, y, and z, so we have 2, negative 1, and 3. So, kung Caltech naman, so we have mode 5, 2. So, that is for 3 equations and 3 unknowns. We have operations on vectors. So, we have position vector. So, that is the position vector. So, the position vector A of the point A, X, Y, Z is written as this. So, we have A is equal to AXI plus AYJ plus AZK. So, the magnitude of your vector A, your R in here, that is magnitude of vector A, that is equal to square root of AX squared plus AY squared plus AZ squared. So, kunin mo lang yung ito, and then you square that, and then add mo lahat. And then we have for unit and resultant vectors. So, unit vector is a vector whose magnitude is equal to 1. and is parallel to a given position vector. So ito siya, yung ating formula. And the resultant vector is a vector representing the sum of two or more vectors. It is done by adding the coefficients of I, j, and k separately. So example natin for this one is we need to find the unit vector associated with the vector 18i plus 3j plus 29k. So for solution, ito siya. Ating given vector is this. And then itong unit vector. So sa Caltech natin, meron tayong options for vector. So that is mode 8, vector. And then same process lang sa matrix, ini-input lang natin yung ating vectors. So 1, so 3. So we have input lang natin yan. So 18i, 18 lang, and then 3 tapos 29. And then to solve for the unit vector, formula mo lang. So, so we have vector A, shift, nasa 5 naman yung vector, shift 5, and then vector A over, ito, saan to? That is the absolute, pwede natin kunin yung absolute value. Kasi that is your A, di ba? Absolute value is ito, nasa height, shift, height, yan yung abs. And then vector A. Shift 5, 3. So, that is how you get the unit vector. So, yan. 0.5253i plus 0.0876j plus 0.8464k. Okay, so ganoon lang yung ano natin for vectors. And then, ito naman, length ng resultant vector. So, meron kang given 3 vectors dito. Okay. And then, ito. Yan. So, pag hinanap ang length ng isang resultant vector, so, ang gagawin lang natin is i-add natin yung tatlong vectors. So, corresponding terms. So, 3i plus 7i minus 16i. So, ito. And then so on. That is the resultant vector. And then the length. So, kunin mo lang yung coefficient nitong ijk. And then, you have the square root of negative 6 squared plus negative 8 squared plus 0 squared. So, that is equal to 10. And then, ito, dot and cross product. So, on dot product, so that is a scalar quantity. So, meron kang two vectors, A and B. So, the dot product of A and B is equal to, ito, resultant of A, resultant of B, cosine theta, or that is AX BX plus AY BY plus AZ BZ. And then, take note, that product is commutative. So, pwedeng pagpalitin. So, the dot product of A and B is equal to the dot product of B and A. And then, example for dot product, ito siya, marami kang solve. Ito solve for this. And then the angle, ayan siya. Dito is solve for the dot product of vectors A and B and the angle between them. Kaya pala may angle. So, yung dot product, so, di ba sabi natin, ayan no, 2 times negative 2 plus 4 times 1 plus 8 times negative 4. So, that is negative 32. So, ito yung dot product ng vectors A and B. So, take note, ang dot product is scalar quantity. Okay? So, sa calculator, again, we input these two vectors. So, shift vector, again, dim. Vector A, input natin. Tatlo yan. So, 2, 4, 8. And then for matrix, vector B, so dim, vector B, 1. So we have negative 2, 1, negative 4. So we have dot product. So shift vector, ito, vector A, 3. Dot product, nandito yan. So shift vector, ayan o, 7, dot. So dot, ayan siya, and then vector B. So we have negative 32. So okay ito. And then the angle between vectors, ayan, negative 32, di ba? So divided by We have negative 32 divided by ito. So, yung abs natin, ito, sa height, and then shift vector A times, ito, abs ulit, absolute, of vector B. Okay. So, we have, ayan, kulang pa. So, ito yung sagot natin, and then we get the arc cosine. So, arc cosine of that, dapat tayo ay naka-degree. Okay. So, we have 139.63 degrees. So, dapat naka-degree tayo, ha? Napansin ko naka-radian tayo, eh. Okay. And then, cross product. Ito naman is vector naman to. Yung kanina scalar, yung dot product, itong cross product is vector. So, ito siya. Gagamit lang tayo ng pag-solve ng determinant natin. So, we have, pwede to, yung naka-determinant, pwede rin itong yung ating mga absolute, yung mga ating mga resultants, pwede itong gamitin. Or, kung gusto nyo ito, yung matrix, pwede rin. So, take note, hindi siya commutative, yung cross product. So, hindi to equal. So, ang cross product in example 12, na, ang sagot is calculator. So, na-input na natin yung vectors A and B. So, cross product. So, have vector 3. Ang cross product, wala kayong makita dito, di ba? Wala. So, input ko yung vector B. So, makuha yung cross product. So, times lang yan. So, times. Ano? Vector A times vector B. So, our answer for this is, ayan, negative 24i minus 8j plus 10k. Ito na yung last nating topic before we can end the session. Medyo ano to information overload yung ating topic. Gradient, divergence, and curl. Gradient of a scalar field. So this is, ang symbol na to is nabla. Nabla, N-A-B-L-A. Okay. Nabla. Yan. So we have the partial derivative of I with respect to x plus the partial derivative of j with respect to y, and then the partial derivative of k with respect to z. So partial derivatives ang concept dito. So ang gradient is defined as the gradient p is equal to nabla phi is equal to this. And then where your phi x, y, z has continuous partial derivatives. And then for the divergence, okay, div A is nabla the cross product, I mean that product of nabla and A. So we have this. And then for the curl, ito ang formula. Nabla cross product ng nabla and A. So ito ay naka-matrix yung ating formula. So last example tayo for the gradient, divergence, and curl. Okay. So ang concept natin, kailangan ay nasa partial derivatives. Okay, so if phi is equal to x cubed, say squared, e raised to y, and a is x e z times I minus xy squared j plus 3x squared z k. So find gradient of a phi, divergence of a, and curl of a. So for grad phi, so that is this one. Okay, so input mo lang yung phi. Ito yung phi natin, di ba? Lagay mo dyan. And then you derivative ka, partial derivative ka with respect to x. So pag with respect to x, okay, yung other variables are treated as constant. So ito, say squared ey, constant na to. So ang derivative ng x cubed is 3x squared. So we have 3x squared, z squared ey times I. Okay? And then pag y naman, with respect to y, constant ito, yung x cubed tsaka z squared. Derivative ng ey, so same, And then, pag z naman, ito, z is, ito namang x cube and ey yung ating constant. So we have 2z, or that is 2x cube z e raised to y times k. So that is how you get the gradient. And then, for divergence of a, we have div a, partial derivatives again. So we have ito, kunin mo ito, x e z, and then negative, negative, take note of this, minus xy squared, and then 3x squared z. Okay, ayan siya. And then same concept for partial derivatives. So we have e raised to z minus 2xy plus 3x squared. And then last, okay, last na tayo. So solving for curl of A. Ito na siya ang problema. Matrix. So solve mo yung determinant. So ganun ulit ang process natin as in your solving determinants. So ito. So we have partial derivative with respect to y of 3x squared z times I. And then we have the partial derivative with respect to z of your x e raised to z. Ayan. And then we have this one, k, and the partial derivative with respect to x of negative xy squared. Okay. Minus ito, partial derivative of with respect to y of x e raised to z times k. And then same again for this, plus partial derivative of with respect to z of this negative x. Teka. Ayan. Negative xy squared. Ito na pala siya. Nandito. Times I. Ito. And then, ito siya. Ayan. We have partial derivative with respect to x of 3x squared z times j. So, partial derivatives tayo. So, you get 0i plus ito. Nandito. And then, simplifying this, minus natin. So, we have minus natin. So we have 0i, and then, ayan, plus x e z j plus y squared k. Ayun. So, simplify natin. Common yung x and j dito sa dalawang ito. Ito, tsaka to. So, you have x e raised to z minus 6z times j minus y squared k. Okay, so that's how you get the gradient, divergence, and the curl of your a given vector. Ito, nandito. Okay, so that ends yung ating session. So sorry, medyo napahaba tayo kasi medyo mahaba talaga yung coverage ni Advanced Math. Hindi ko pa nasama yung ibang topic na medyo mahirap kasi ito namang na-discuss ko is sufficient enough for you to sa board. So enough na siya yung ating concepts na discuss. Kasi yung iba ng mga power series, Fourier series, medyo ano na yun. Lalabas man siya pero pang ano na lang, mga pang top notcher na yun, di ba? Okay, so thank you for listening and have a good day.